Namaste and a very good morning to all of you. I welcome you to my channel, The Outlier. My name is Mithun. In today's video, I'll be talking about reliability analysis. If you are a research scholar or if you are pursuing any form of research, this is a good video for you to watch. Even before I proceed to demonstrate what exactly is reliability analysis, may I request you to subscribe to my channel, also like and share my videos. In this video, we will be speaking about two different methods of obtaining reliability analysis. The first is what is called as the Cronbachs Alpha. The second method is what is called as the split half method. Let's now talk about the first method, namely the Cronbachs Alpha. Even before I proceed to talk about the Cronbachs Alpha, I'd like to introduce the data set to my audience. As you can see here, I have different questions and a rating measure. For example, the first question has been rated as 5 by the first user. He has given a rating of 4 to the second question, the rating of 4 to the third question, so on and so forth. If I scroll to the extreme right side, you can see there are 25 items in this scale. I would like to measure the internal consistency and the reliability of this questionnaire. It's a good question to always ask, that is, what is the sample size in this data? As you can see here, I have approximately 689 different samples. So we will be obtaining the reliability analysis of this model. To perform reliability analysis in SPSS, what you need to do is click on the Analyze menu bar, proceed to the Scale option. Here, the very first option is Reliability Analysis. Let me go ahead and select the Reliability Analysis option. As you can see here, this opens up the Reliability Analysis dialog box. In the canvas to the left-hand side, you can see all the items in the questionnaire. There are 25 different questions. Let me go ahead and select these 25 questions and click on the arrow. So these are the items whose reliability I'm interested in estimating. When you look at the bottom half of the dialog box, you have an option which is called as model. The default option here is alpha. This will give you what is called as the Cronbachs Alpha. When we click on the drop-down menu, there are other options as well. As you can see, you have what is called as the split half method, the Guttman method, the parallel approach, and the strict parallel. In this video, I will be speaking about the first and the second methods only, that is alpha and split half method. For those of you who are very new to the Cronbachs Alpha method, let's begin by asking a simple question. What is the Cronbachs Alpha? The simple answer to this question is that a Cronbachs Alpha is a measure of internal consistency. I repeat, the Cronbachs Alpha is a measure of internal consistency. What does this mean? This means that the Cronbachs Alpha helps us understand how well the items in a test measure the same underlying construct. Cronbachs Alpha is calculated based on the average inter-item correlation among all items in the test. Its value lies between 0 and 1. I repeat, the Cronbachs Alpha ranges from 0 and 1. If you get high values of Cronbachs Alpha, that indicates better reliability. I repeat, if the Cronbachs Alpha is close to 1, it means that your questionnaire is highly reliable. Typically, values above 0.7 are considered as acceptable, above 0.8 are considered as good, and if the Cronbachs Alpha is above 0.9, your questionnaire can be considered as excellent. Let's also understand what are the different advantages of using the Cronbachs Alpha. The first is comprehensive assessment. Cronbach's Alpha considers all the pairwise correlations among items, providing a thorough evaluation of internal consistency. Second, Cronbach's Alpha is widely used and widely accepted. It's a standard and widely recognized measure in the field of psychometrics and research. Number three, Cronbach's Alpha is very easy to interpret. The alpha quotient that we get is very simple, easy to interpret with higher values indicating higher reliability. Number four, adaptable. Cronbach's Alpha is applicable to a wide range of tests and questionnaires, making it versatile for different research needs. Like with any statistic, Cronbach's Alpha also has its disadvantages. Many times people ask me, what are the disadvantages of Cronbach's Alpha? This point may be slightly technical. The first important disadvantage of using the Cronbach's Alpha is that the Cronbach's Alpha statistic assumes tau equivalence. I repeat, it assumes tau equivalence. Now you may ask me, what does that mean? Cronbach's Alpha assumes that all items have the same true score variance, which might not always be the case. If I have to break this down, in our data, we have 25 different items. Cronbach's Alpha makes the assumption that all of these items have the same true score variance, which is idealistic. Number two, Cronbach's Alpha is highly sensitive to number of items. If there are more items, what happens to Cronbach's Alpha? More items can artificially inflate the alpha value, giving a potentially misleading sense of reliability. This is where we should be very, very cautious about using the Cronbach's Alpha. Thirdly, it is not informative for item level issues. Cronbach's Alpha does not provide information about which specific items may be problematic or reducing overall reliability. So for example, out of the 25 variables that I have taken, it may happen that variable number 17 may be bringing down the overall reliability. Cronbach's Alpha is quite silent about this piece of information. The fourth point here is that Cronbach's Alpha is affected by item redundancy. If items are too similar, it can inflate the alpha value, giving an impression of higher reliability than what actually exists. For example, if question number 2 and question number 3 are very, very similar, you can expect the Cronbach's Alpha to shoot up. This does not mean that your reliability is high. Now, we ask a very, very important question, which is useful to research scholars. What is the optimal number of Cronbach's Alpha? Typically, if the alpha value is above 0.7, we can consider it acceptable. If the alpha value is greater than 0.8, it means the questionnaire or the scale is good. And if the alpha value is higher than 0.9, it means that the scale is excellent. A very important point here, the number of items that we use. Cronbach's Alpha is ideally suited for tests with 10 or more items. I repeat, this is very important because many times people ask me, for how many items should I use the Cronbach's Alpha? Cronbach's Alpha is ideally suitable for those tests with 10 or more items. With fewer items, the value of Cronbach's Alpha might be lower due to fewer pairwise correlation. I like to ask the next important question. When do we use Cronbach's Alpha? I repeat, when do we use the Cronbach's Alpha? Comprehensive reliability assessment. You can use the Cronbachs Alpha when you need a thorough evaluation of the internal consistency of your entire test or scale. The second important point here is large item sets. Cronbachs Alpha is ideal for tests with large number of items, generally 10 or more, where pairwise correlations among all items need to be considered. The number three, standardized tests. Cronbachs Alpha is suitable for well-established tests where the assumption of tau equivalence is more likely to hold true. If you are going to use Cronbachs Alpha for a new scale, you might want to be careful. Number four, developing new instruments. Cronbachs Alpha is helpful when creating new skills or questionnaires to ensure high overall reliability. So these are the four important things to be kept in mind when you are using Cronbachs Alpha. One, comprehensive reliability assessment. Second would be large item sets. Third would be standardized tests. And fourth is when you're developing new instruments. With this background, let us now generate the Cronbachs Alpha value for our questionnaire. All that you need to do is select the questions, make sure that you have selected Alpha option under the model section and hit the OK button. What you're seeing here is the output window. SPSS generates a lot of information here. The first table is not that important because it is just giving you summary information. What is the sample size? How many cases have been excluded here? And what is the total number of rows that we have? This small table that is reliability statistics is very, very important. You can see here, SPSS prints the Cronbachs Alpha value. And here the Cronbachs Alpha that I am getting is 0.985. I repeat, 0.985. The questionnaire that I'm using is an established questionnaire. And since this is a standard test, it is expected that Cronbachs Alpha is on the higher side. Whenever the Cronbachs Alpha is greater than 0.7, your questionnaire can be considered as good. The number of items that I had supplied here is 25. I'd like to draw your attention to a very important point. It is very easy to get confused when you're writing a research paper about the interpretation of Cronbachs Alpha. Here is where there is a very powerful option in SPSS, which is called as what is this? To help you interpret the Cronbachs Alpha better, you can go ahead and double click on the Cronbachs Alpha. Simply right click on this statistic and this produces a menu, and right at the top you can see what is this option. This is a very, very useful option, and I would like to encourage my audience to use this option. What is this? Let me go ahead and select this option. What is this? You can see here SPSS displays the interpretation of Cronbachs Alpha. Let me read it for the benefit of my audience. Cronbachs Alpha is a measure of reliability. We know that it's a measure of reliability that is a lower bound for the true reliability of the survey. I repeat, this is a measure of reliability that is a lower bound for the true reliability of the survey. The computation of Cronbachs Alpha is based on the number of items on the survey and the ratio of the average item covariance to the average item variance. The last point is slightly technical and avoidable. However, if you are a user, you can just watch out for the final value that you get. If it is greater than 0.7, you are safe. On the other hand, if your Cronbachs Alpha is lower than 0.7, it means that there is a problem with the questionnaire. You might want to consider dropping off those items which are bringing down your overall Cronbachs Alpha value. Now, I'm going to proceed to explain the second method that you can use for reliability analysis. Besides Cronbachs Alpha, there is another method which is not as popular as Cronbachs Alpha. However, it does as good a job. Let me now go to the Analyze menu bar. Here, we have the option called as Scale. I'm going to go back to Reliability Analysis. You can see here, these are the earlier selections that I had made. Under the model section, the default option is alpha. Let me click on the drop-down menu and choose the method split half. I repeat, this is called as the split half method to perform reliability analysis. Now, in case you're very new to the split half method, I'd like to clarify some important points about the split half test. The split half test is a measure of internal consistency. Now, there's an important caveat here. The split half test, as the name itself suggests, split half. This procedure involves splitting a test into two halves and then correlating the scores of these halves. The correlation is usually adjusted using the Spearman-Brown formula to estimate the reliability of the entire test. Let me simplify what I've just now explained. As you can see, I have taken 25 variables in this data set. I've taken 25 items. What the split half method does is it splits these 25 into two parts. The first part may have around 13 questions. The balance 12 questions will be put in the second bucket. So we are going to categorize these 25 questions into two separate buckets. The first bucket will have 13 questions. The second will have 12. We will be finding the Cronbachs Alpha for the first set of 13 questions. Also, we will be finding the Cronbachs Alpha for the balance 12 questions. So you will effectively have two separate Cronbach Alpha value for the first part and the second part. In the next step, we combine the original Cronbach Alpha obtained from estimating the model for the first set and the second set. Now, there are many different advantages of the split half tests. The first big advantage is the simplicity. It is easy to compute and understand, making it accessible for quick reliability assessments. The second point is very important. The split half test is practical for very small data sets. Split half method is suitable for small data sets or when a quick estimate of the reliability is needed. In other words, if you are doing a pilot study and if you want to obtain the reliability of the set of questions, you can use the split half test. The third point is that there is no assumption of tau equivalence. In the case of Cronbachs Alpha, there is the assumption of tau equivalence. Here, in the case of split half test, this test does not assume that all the items have the same true score variance. Number 4, the split half method is good for exploratory analysis, useful for exploratory analysis and initial reliability checks during test development. Like with any other statistic, we also spoke about Cronbachs Alpha and its disadvantages. Though this test is very powerful, it has its own set of disadvantages. Let's now examine some of the important disadvantages of the split half test. Arbitrary splitting. Reliability can vary depending on how the test is split, leading to inconsistent estimates. What does this mean? As you can see here, question number 2 is in position number 2. If you were to take question number 2 and put this in the last of the list, you will get a different value of split half, and it is not very, very consistent. Because there is an arbitrary way of splitting, it becomes very difficult to rely on the split half method. Number 2, This test is not as popular as that of the Cronbachs Alpha. It has limited scope. It provides a reliability estimate for a particular split, not necessarily generalizable to the entire test. Number three, this is less comprehensive as compared to Cronbachs Alpha. This does not use all item correlations, potentially missing interactions between items. Next, after you perform the split half test, there is a need for an adjustment to be made. So this point we are calling as adjustment needed. That is, this test requires adjustment. Typically, we use what is called as Spearman-Brown formula for the adjustment. Now, the adjustment is needed to estimate the reliability of the whole test accurately. So these are the four important disadvantages: arbitrary splitting, limited scope, less comprehensive, and adjustment is needed for the split half test. Now, the one question that people ask me is, what is the optimal number for the split half test? I said that for Cronbachs Alpha, it is greater than 0.7. What is the optimal number for split half test? Typically, split half reliability values should be high, similar to Cronbachs Alpha, with values above 0.7 being acceptable. So if you are getting a split half value of bigger than 0.7, you can call the scale as good or a reliable scale. Now, what is the optimal number of items for the split half test? The split half test works well with tests that have a moderate number of items. That is, if you have anywhere between 10 and 20 items, your split half test is reliable. Tests with fewer items might not split effectively into two reliable halves. What does this mean? If you barely have 5 items in the scale, better not to use split half. On the other hand, if you have more than 10 and fewer than 20 items, your split half tests can be relied upon. When do we use the split half test? There are 4 important considerations. Quick reliability test is the first one. You can use the split half test when you need a quick and a straightforward estimate of reliability. The second important test is for small data sets. The split half test is ideal for small data sets where complex calculations may not be feasible or necessary. If you're doing a pilot, split half works very well. Number 3, for exploratory research. The split half test is suitable for preliminary analysis and initial reliability assessments during the development phase of a test. Let's now focus on the fourth important criteria, which is when the tau equivalence assumption is questionable. I repeat, when the tau equivalence assumption is questionable. What does this mean? The split half test is useful when you cannot assume that all the items have the same true score of variance, providing an alternative perspective on reliability. Now, by understanding the optimal values and appropriate use for Cronbachs Alpha and the split half test, you can better assess the reliability of your instruments in various research scenarios. Now, I've given you an overall background of the split half test. It is time for us to see what is the output that we can expect from the split half test. So we're all set to calculate the split half test for this particular questionnaire. Let me go ahead and hit the OK button. You can see here, we are already familiar with this small table, case processing summary. I'm going to ignore this. Let's now come to reliability statistics. You can see here, the Cronbachs Alpha is divided into 2 parts, part 1 here and part 2. For the first part, you can take a look at the number of items, that is 13. We have 13 questions belonging to part 1. And in part 2, you have 12. Remember, the original number of columns that I had is 25. So 13 plus 12 would be 25. When you look at the Cronbach's alpha value for part 1, it is 0.968. And when you look at the Cronbach's alpha for part 2, it is 0.975. Both of them are on the higher side. If you're interested to know which all questions rather are part of the first set, you can take a look at the description here. The items are question 1, question 2, question 3, all the way up to question number 13. Similarly, if you're interested to find out which all questions belong to the second set, from question 13 all the way up to question number 25, you have part 2, and SPSS has calculated the Cronbach's alpha value separately for the second set. Now, how do we interpret this? The Cronbach's alpha value is 0.968 calculated from 13 items, that is question number 1 to 13. For the second part, it is 0.975 calculated from 12 items, that is question number 13 to question number 25. Because the number 25, we have 25 questions, which is an odd number, it's a bit difficult to split 25 questions. If you had 26 questions, the first 13 would be put in the first part. The balance 13 would be going into the second part. Now, have a look at the value, which is 0.941. This is an important number here, which is the correlation between forms. The word forms here represent the two parts, that is part 1 and part 2. You can interpret this as the combined value of the Cronbach's alpha, that is 0.968 and 0.975 is getting combined, and we are calculating the overall value of Cronbach's alpha, which is 0.941, which is on the higher side. The correlation between the two parts or forms of the test is 0.941. This indicates that there's a strong positive relationship. Now let me go to the second half, what is called as Spearman-Brown coefficient. What is the Spearman-Brown coefficient? You can see here there are two parts. One is equal length and the second one is unequal length. Now, how do we interpret this? The Spearman-Brown coefficient for equal length, right? The Spearman-Brown coefficient for equal length halves is 0.969. Now, the Spearman-Brown coefficient for unequal length is also 0.969, suggesting consistency and reliability across different methods of splitting the test. Last but not the least, we have to pay attention to what is called as the Guttman split half coefficient. I repeat, this is called as the Guttman split half coefficient. Now, the value that I'm getting for the Guttman split half coefficient is 0.969. Please observe, this is highly consistent, 0.969 for equal length, 0.969 for unequal length, and the Guttman split half coefficient is again 0.969. This indicates very strong internal consistency reliability. I repeat, because we have a number which is greater than 0.7, we can conclude that there is very strong internal consistency of reliability. Now, overall interpretation of this entire table can be put in 2 or 3 lines. The first is with respect to the Cronbach's alpha value. Both parts of the test, that is part 1 and part 2, demonstrate very high internal consistency, that is 0.968 and 0.975. They demonstrate very high internal consistency with values well above the commonly accepted threshold of 0.7. The second point here is about the correlation between forms. The strong correlation, that is 0.941, that is 0.941 between the two parts, suggests that both parts of the test measure the same underlying construct effectively. Now, these are very powerful words. that because we have got such a high value, we can conclude that both the parts of the test measure the same underlying construct effectively. And finally, we move on to the Guttman split half coefficient. The Spearman-Brown and the Guttman split half coefficients. These coefficients further confirm the reliability of the test, showing consistent results across different methods of splitting the test. So this is how you can interpret the reliability statistics. If you're slightly new to SPSS and hence statistics is unfamiliar, I would encourage you to double click on some of these statistics, right click and use the what is this option. You can clearly see that SPSS provides an explanation. It says the Spearman-Brown coefficient is a measure of reliability that split the scales, that treats the split scales as items on a 2-item scale and uses the correlation between forms as the basis of the statistic. The unequal length version of the statistic adjusts for split scales with different number of items. You can obtain an explanation for the Guttman split half coefficient as well. You can follow the same procedure, right click and click on what is this. You can see here what SPSS says. It says this is a measure designed to answer the question. What is the question? Given two parts of the scale, how reliable would the whole be if they were combined into one? Very, very simple, pointed, and effective. Given two parts of the scale, the Guttman split half coefficient tells us how reliable would the whole scale be if they were combined into one consolidated scale. It is similar to the Spearman-Brown coefficient, but it does not assume equal reliabilities. So this is one of the advantages that we have. We are not assuming equal reliabilities or equal variances for the two parts. Again, you can select this part and hover the mouse on top of the number 13. You can see SPSS gives an explanation for all the items that it has considered under the first part. We can do the same thing for B. You can see SPSS displays all the items that it has considered to generate the Cronbachs Alpha for part 2. With this, I have come to the end of today's video. In today's video, we have seen Cronbachs Alpha. We have also seen what is the split half method. Specifically, we obtained two important measures, that is Spearman-Brown coefficient and the Guttman split half coefficient. Thank you very much for watching this particular video. I request you to subscribe to my channel, also like and share my videos. Thank you very much once again. Have a great day ahead.